Hi, Andrew. So first things first, who are you? What's your role? And where do you work?
Well, my name is Andrew Hillier. I'm the CTO and one of the co-founders at Densify, a Kubernetes optimization company.
And what are three emerging Kubernetes tools that you are keeping an eye on?
Well, the biggest one for me by far is in-place resizing. That to me is, I don't know if you call it a tool, but a capability. But we do a lot of work on optimizing requests and limits, and a lot of work on automation of that, and that's kind of a godsend for us because we can do what we do and much faster and much more easily. So I think that's one of the big ones. I mean, that towers above all the others. We keep an eye on things like OTel because of course we're always hungry for data and better ways to get data and like to avoid Prometheus, any issue with that or whatever. So, I mean, that's the other one. That's the other one I mentioned. I'm having trouble thinking of a third right now because we're so focused in that area of getting the data, analyzing it, automating it, and optimizing the environments. I guess, of course, Carpenter is a big one for us as well. That's not that new, but that also is a very nice complementary technology because it automatically makes the cost go down when you optimize the container. So it's quite a nice technology in our mind.
Now, one of our podcast guests, David, thinks that developers didn't fully understand the fundamental differences between containers and virtual machines. How do you help teams understand containerization when they're coming from VM backgrounds?
Well, it's a topic that's near and dear to my heart, actually, that one, because we have a background in VMware optimization going way back. I do, and it had overcommit, and the resources were virtual. So if I didn't have good utilization of my hosts, I could just overcommit the CPU and memory. I could give it away more than once and fix that centrally. And I think people go into Kubernetes believing it does that because it talks about things like overcommit, but it's not the same kind of overcommit. Overcommit in the Kubernetes world is kind of you going above your request but below your limit, but you're not scheduling out the same resources more than once. So you get stuck in this low utilization world, and the only way out of it is to fix your requests and limits. But people have a misconception. I think they think there's some magic in there that will make this work better and make your utilization go up. When really, if you ask for 10 CPUs, it'll earmark 10 CPUs for you. You can share them with other people or other containers, but when you give out all the CPUs, you start a new node, and that makes it very expensive and very low utilization. So that's definitely the biggest misconception. The VMware technology has virtual resources and overcommit, which is very different and actually quite useful for driving efficiency.
One of our other guests, Zane, observed there's a lot of waste happening on CPU and GPU, and there's a significant opportunity to optimize this. What approaches do you take to reduce resource waste in your clusters?
So CPU, both those are big. Memory, there's waste too, but memory, there's also under configuration. So when we analyze memory, we find it's a mix that some are too big and some are too small, and you might actually be okay, but it's all given to the wrong containers. So, but CPU is universally too big. We find that it's just difficult for an app team to estimate what request to give something. You usually want to request something that's kind of related to when you're busy or what you need to do. But if everybody does that, then you end up with a lot of stranded capacity. So that's by far the biggest CPU. We see tons of stranded capacity, a lot of capacity on the floor and utilization, under 10% on average for those things. So GPU is a new area. We just deployed our new GPU optimization, and we're hitting NVIDIA GPUs in customers, and yeah, there's a lot of opportunity there, a lot, capital LOT, because I think we're even seeing cases where people don't have the DCGM exporter installed and they're not even seeing what they're doing. So, but you'll see a GPU and AI workload that's using a quarter or an eighth of a GPU at peak, and there's an opportunity there to do MIGs, and slicing and divide them up on the right GPUs. And so that's a big focus now because one recent customer I was working with, you can chop it in half. You can just literally chop the $4 million spend down to $2 million by just slicing up the GPUs. So there's a huge opportunity there. It seems to be trending along with CPU where, the workloads ebb and flow. And so it's hard to figure out what you need. Memory is usually a little more flat. And so people overestimate and create a ton of waste. And GPUs are so expensive, it just adds up really quickly.
One of our other guests, Gregors, said that using managed Kubernetes services like AKS makes things easier because it takes a lot of work to set up and operate a cluster. However, it also comes with its own set of challenges. What challenges have you faced with managed Kubernetes services?
Well, I think so. And absolutely, from a configuration management perspective, it makes it a lot easier when everything's bundled and stands up together. Again, just from the rock we stand on, we see the same problem. It doesn't solve the problem that we solve, where if people make the request too big, you'll still run on a lot of infrastructure. It'll automatically run on a lot of infrastructure, but it'll still run on a lot and cost a lot of money. And I should mention also, if you make things too small, if you make your memory limits too small, you get out of memory kills. We do a lot of analysis around that. So you have risk and you have cost. And in our view, and we've done a lot of analysis across our customers, there's very little difference between whether you're on a kind of a homegrown or a service like an EKS or an AKS or an OpenShift. They all exhibit the same challenges from a capacity perspective. If your CPU requests are too big, again, you'll just have large scale groups or scale sets running. And I mentioned Carpenter earlier. Even running Carpenter doesn't solve this. If you ask for twice as much CPU as you need, Carpenter will just run nodes, twice as many nodes or node CPUs, because it has to give you what you asked for. So these things, I think, are extremely. I mentioned Carpenter earlier. It's extremely convenient because it does auto consolidation. It manages things very nicely. It doesn't solve the spend problem, because if app teams are asking for too much, it still has to abide by those requests. So none of these technologies solve that problem, but they're obviously very, very useful for making lives easier for the platform teams.
Every month, Andrew, we do a content analysis report where we look at all the different content shared across our network. And we've seen a couple months ago, actually, the top trending topic was resource optimization, looking at cost management, performance tuning, scale to zero solutions. Mm-hmm. In your experience, what have you found to be, topics that get the highest amount of response from people in the community? Obviously, everybody wants to save costs. Everyone wants to optimize. But when it comes to specific topics or things that people are having, difficulties with, challenges with, what do you see the response from the community when it comes to that?
Well, so I'll rewind a bit. Like in the cloud world, spend has always been, and resource optimization was always the biggest problem. And to this day, there's challenges in getting it fixed. You can say, oh, we're spending twice as much, but to get people to actually change their cloud instances is a bit of a heavy lift, because there's a lot going on there. There's configured storage. There's all these things that you want to make sure you get right if you change it. And in Kubernetes world, we find it's much more streamlined as far as fixing it, because it's basically requests and limits, and nobody's emotionally attached to the request or limit. As long as they understand why it's being set to what it is. And so the biggest thing we see on that front is by far automation of that. And we've been doing a lot of work of automation, and it's being adopted pretty quickly, because I think people want to understand why you're saying that settings should be what they are, and then if they agree with it, just do it. I don't need a PhD in analytics to let it do it. Just turn the machine on and do it. So we're seeing a lot, which is great. We're seeing a lot of that happening, where you can actually flip the switch and automate, and then things just start getting better. And it's we have this visualization in our product where you can visually see if things are too big or too small or just right, and you can visually see things getting better, almost dynamically in the environment when you turn on automation. So that's the biggest thing. I think the waste, and of course now I mentioned risk as well. If I have things hitting their memory limits or CPU limits, or things are undersized, automating that is the key as well. You don't want to manually be tracking down all these things. Just let the machine fix it. So that's by far, in our mind, is the hot topic lately. Is that if we put a booth at a trade show saying, cut costs in Kubernetes, we get a lot of reaction to that now. Maybe a couple of years ago you wouldn't, because people weren't aware how expensive it was yet. Now people are, but the conversations very quickly go to automation. Like, okay, I just want to fix this, and then I want to walk to another booth and figure out how I solve my security problem. So that's great for us, because again, that's what our focus is once you trust the answers, you just do it, and then don't worry about it. I think that's where everything's going to go eventually as organizations mature.
And what's next for you?
Well, I mean, there's AI is kind of the standard answer from everyone on that one. We're doing a lot on that area. There's two sides. Our GPU stuff I just mentioned, we just released, is really targeting AI workloads. We see a lot of them in our customers. AI inference running in Kubernetes is pretty hot, and there's a big opportunity there. But also AI within the product. I won't talk into too much detail about that, but we're doing some really cool things to interpretation, intelligent notifications. Really is taking to that next level. So if you're running a big environment, maybe you just want to know what my worst problem is, or what my top cost areas are, or tell me when this happens. Tell me if something unusual goes on. So we're doing a lot of work in that area, where it's really kind of standing on the back of the deep analytics to then say, okay, we're going to take it to the next level. And so you'll see some new stuff from us coming in the coming months on that front, which is quite exciting.
And Kubernetes turned 10 years old last year. The CNCF's turning 10 years old this year. If you could go back, 10 years time and give yourself one piece of advice of, hey, you're going to be starting out with this technology. My advice would be to pay attention to this particular aspect. What would that be and why?
That's a great question. If you go back in time, I think there's a couple things come to mind. I mean, I think everything takes longer than you think it's going to take. 10 years sounds like forever. And I think at any point in that 10 years, you probably thought, the world will be transformed in the next year or whatever. But we see the same problems kind of take a long time to, again, just even what we do, right? It's even taken 10 years for people to realize that, to truly realize that this is going to be a very expensive thing to run if you misconfigure it and that kind of thing, or that there's risks involved. And I think, I think that's the biggest thing. And I think people want the ecosystem like our product to just solve it for them. And that takes time to happen. So I think there's kind of a be patient kind of thing in there where everything takes a bit longer. But again, I think the other thing would just be that really focus on the fact that we talked about the outset, the overcommit thing. There's no magic here. This thing doesn't magically solve all your problems. It just takes the same problems you had and makes them look a bit different. You still have spend problems, you still have performance problems, and you need to solve them and really keep the eye on the ball. Because I think it's taken everybody a while to realize that, and I think it could have been realized sooner. And because there's a lot of spend out there that could have been avoided over the years. Although I think now we're still a good time to solve it, because really we see a lot of ramping of Kubernetes almost everywhere. So if better time would have been a few years ago, but now is the second best time to fix it.
Very good. And with that in mind, Andrew, if people want to get in touch with you, what's the best way to do that?
Well, I mean, I guess the best way is, I'm findable on LinkedIn and all these things. We can probably post that, but our website is a great source. Just there's a lot of good resources on there. You can find me if you click in the right places on there. But the other thing I'll mention there is we have a really cool sandbox on our website where you can just go into our product and click around and see what I'm talking about. You can see the visualization of the resources in the Kubernetes environment. So it's pretty rich experience that you can just go and access. So if anybody wants to see more detail about what I've been describing, you can just go in and actually use our product against demo data. It's pretty neat.
Perfect. Great. Andrew, always a pleasure to talk to you. Take care. We'll speak soon.
Yeah. Thanks, Bart.
Cheers.